All right, so this is a lesson on pointers. Now, pointers are something that a lot of students find confusing, okay, or hard to understand. But really, they're not so bad, especially for what we're gonna be using them for, or actually, we'll be using them later if we ever get to it. But I want you to understand what they are. Um, and before we talk about pointers, let's talk about memory locations, right? Memory locations are like little addresses or little cells inside your RAM in your computer, right? And they all have a little address to them. And those addresses, memory locations, are in hexadecimal, right? The reason why they're in hexadecimal is because if now uh, when it comes down to it, they're stored in zeros and ones, just like anything else. However, when they're outputted, right, it's going to output in this form. If it wasn't, you just have a huge string of zeros and ones. So when we actually, so again, this column is what kind of look what your RAM looks like inside your computer. And when we say something like int m, right? Well, that's it takes m and it chooses a memory location to store it in m, right? So this right now there's no value to it, but it's going to use that memory location in our computer, in our memory, in our RAM. And then I'm going to say int or m equals 8, right? That's the value there. It's stored as 8, and it lives here in this memory location. Back um, before coding was a little bit easier like that, we actually had to use these hexadecimal numbers to store uh, variables. We didn't. It wasn't easy to as just using m. We had to use these. And when I say we, I mean humans. Uh, as early as the early 70s, right? We had to do this. So that's what happens if I say double um, x equals 7.2. It's kind of like saying x and 7.2, right? If I say char t equals the dollar sign, it's like this. It'll choose a memory location that's available. Let's say this one's available here, and it'll store that character and so forth. So yeah, it's not quite as simple as this, but this is okay just for learning what this is. So a pointer now, right? A pointer, or sometimes they're referred to as references, stores memory locations. Pointers store the memory locations of other variables. For example, if I wanted to store the memory location of m, right? And again, you might find this not useful now, but it is useful later on down the road. And I just want you to be aware of these things. So before we move on, let's talk about how we declare a pointer, right? We declare a pointer just like any other variable. And it has to have a type plus a name for it, right? That we can use as a programmer. So we have a type. The only difference is you have this little star here. So we have a type int, and then we have a star p, or we can put the little star next to the t. It doesn't really matter depending on your. Actually, either way it'll work. So this declare, when we declare a pointer, we have to say the type that it's going to be pointing to, right? Pointers. This guy right here is a memory location. It's going to be one of these, right? But it's going to point to an integer. So the first thing we have to do is declare a pointer. So, and what type it's going to be pointing to. So I just declared a pointer called p, and it's going to point to an int. And then I have to point that pointer to a certain variable. So let's say we have x equals 5 here, in x equals 5, right? So that would actually, let me get rid of these guys. So let's say I have x equals 5 here. Matter of fact, this guy right here, when you do this, it's going to choose a memory location, right? The pointers have to live in a memory location too. It's just that they're going to store, their value here is going to store a memory location, one of these over here. So when I say int star p, it's going to put a p there. P lives in this. Now there's no value yet to it, right? So let's say I have x equals 5, and that's going to say, it's going to find a memory location, and in this case it has value. Now, to point p to x, right? P is going to store this memory location of x, but I have to point it. I have to say p equals, and I can't just say p equals x, because x is an integer and p is a pointer. So what we say is ampersand a. And what that does, ampersand means literally the address of, right? Well, the address of x is this guy right here. So it's going to store that. So p is actually going to store that value. P lives here, but it's storing this value here. All right, let's do another example. So let's say we want to declare a pointer that's going to point to a double. So we're going to say double, and then amp or star. Say we'll call it t. Right. So t appears in memory here, right? And it doesn't have a value yet because we didn't point it to something. Well, we need a decimal number to store it to. So let's say double num equals 7.88, right? So num finds a available space here. Num, that's storing 7.88, right? And num lives here. So now we have to take t and point it to the memory location, ampersand, I'm sorry, t equals ampersand the memory location of m. And once I do that, t is going to store this guy right here. There we go. All right, so we're almost done here. If I wanted to see out any of these guys right now, if I seed out p and then see outed x and then see outed t and then see outed num, right? Well, what would this output? Well, p, right, is storing the memory location of x. So that's going to output this, right? That's going to output that. If I see out x, well, nothing new there. It's going to see out 5. If I output t, right? If I output t, it's going to, t is storing the memory location right now of num. So that would output this. And of course, num, nothing new there, would output 7.88. Right? These are the answers if you were to output these. All right, so a couple things here just to note. I can dereference a pointer. I can dereference if I say see out p, right? If I see out p, I get this, right? Well, I can dereference p. If I say see out star p, right? All that does is output what's stored in this memory location, the value. Well, that's simply 5, because P is pointing to the memory location of X. It's storing this memory location, but the value in X is 5. So just like saying C out X, I can say C out dereference the pointer P, and I'm going to get 5 here. I can also output the memory location of X by saying memory location of X, and that will store the same thing P is pointing to, which is the memory location of X. Matter of fact, I can even output the memory location of P if I want, right? Again, even though P's a pointer, it has to live somewhere. So the memory location of P is this guy right here. That would output that right there. All right, so just try to read this. All you have to know in this is how to declare a pointer, right? How to point a pointer to something right there, and how to output a pointer, right? And dereference a pointer. That's it. Don't think too much more into this. That's all you're gonna have to know for this and for the test, and there'll be a review for the test too. So you'll be well prepared.